Hello, and this time we're talking about radians, but we're looking at arc lengths and sector areas. So we'll start by saying what do these things do in degrees, and then convert it into radians. So hopefully you remember how we do this in degrees. If we've got some sector here made by an angle at the center, then we can make a formula for the length of that arc and also for the area. And it's simply a fraction of the full circle. If we had the full circle, then the circumference is 2 pi r, and the area is pi r squared. But if we just want a fraction of that, and that's some angle of 360, so we get the fraction from the angle, then the arc length is going to be that fraction times 2 pi r, and the area of the sector is going to be the fraction times pi r squared. We can do this in radians as well though, and if we do it in radians it's exactly the same. It's just going to be the angle in radians over a full circle in radians. Just like here, it's just the angle in degrees over a full circle in degrees. So we can do exactly the same thing. In radians, this is going to be, so this is in degrees, so we should put a little degrees symbol on. If we do it in radians, it's going to be the angle in radians over a full circle 2 pi times 2 pi r. Okay, let's write that out a bit better. I missed off the 2 times 2 pi r. But of course we can cancel this. There's a 2 pi here and a 2 pi here, which means this is really easy. The arc length in radians is just the angle in radians times the radius. That's it. Really straightforward, really easy. The area is very similar, not quite as nice as a formula, but it's still the angle we want in radians, and it's divided by a full circle in radians times pi r squared. Well, in this case, the pi's are going to cancel, but that's it. So the area formula in radians is the angle, half the angle, so we've got the half there, in radians times the radius squared. So it's not quite as straightforward as the arc length, but there's still, the pi isn't there because the pi is incorporated in the angle itself. Yeah, the measure of the angle includes that value of pi built in from the radians. And that's it. Those are your two formulae, so here and here, and this is just what we use then to solve questions. And it could be quite a tricky question, or it could be quite an easy question, but they're no different from if it was in degrees. That's just sort of how you then process the question. One thing I will add is that you can work out, and this is true in degrees as well as radians, you can work out the area of a segment like that. If you cut a segment off, and it can be a bit bigger, we can have a huge sector and then get the segment area quite nicely. And that's quite straightforward because all we do is the whole sector area, which is this down here, and we take off the area of this triangle. And because this triangle is made with the radius there and the radius there, and the angle in between, then we can just use the formula half the two sides, so that's r squared, times sine of the angle in between them, which we'll write as theta. And that will work whether it's in radians or whether it's in degrees. You just have to have your calculator in the right setting. So on your calculator, see here there's a little d in a box. So if I was to do this question and put in 30 degrees, it will give me the area of that triangle. But if I was given it as pi over 6, then I'd have to go to Shift Setup. Nope, didn't press Shift properly. Shift Setup, Angle Unit, and put it into radians. Now I've got a little r to say I'm in radians. And now if I put the angle in radians, then it will give me the area again. Okay, but obviously it has to be in the right units, otherwise the calculator will assume if you have it in degrees, it'll assume you put degrees in, and you'll get the wrong answer if it was actually in radians. Good habit is to always put your calculator back, because when you're doing radians, it's easy to remember to put your calculator into radians. But when you're doing degrees, you just kind of assume your calculator is in degrees, and that can lead to issues. So always a good idea to pop that back. And if you want the area of the segment, then it's simply the whole area of the sector minus the area of the triangle that you don't want. And that'll give you the area of the segment. Sorry. Here's a question to go through as an example, so you can see it in action. A sector of a circle of radius r contains an angle of 1.2 radians. So let's have a diagram of that. If you can excuse my terrible drawing. So we've got this sector here, 1.2 radians in the middle, and a radius of r. Given that the sector has the same perimeter as a square of area 36, find the value of r. Okay, well that's fair enough. A square of area 36 is going to have sides of 6 by 6, because 6 times 6 is 36, which means it's going to have a perimeter of 24. And this tells us that the sector has the same perimeter. Now you've got to be careful, because it hasn't said the arc length, it said the perimeter, which means the arc length plus the radius plus the radius. So we can say that 24 equals the radius plus the radius, 2r, plus the arc length, and because it's in radians, it's just the angle times the radius. The angle in radians times the radius. That's what we saw previously. And now this is just an equation, and we've got everything we need to know other than the radius. So this is, we substitute in 1.2. 2r plus 1.2r is 3.2r equals 24, and therefore r is 24 divided by 3.2. Nice and straightforward. Here's another question, this time involving areas as well. So a sector of a circle of radius 28. So let's draw that on, that's 28. Has perimeter P and an area A. Given that the value of the area is 4 times the value of the perimeter, find the value of the perimeter. Okay, well we can say that the area is, and we can use the formula, so that's half theta in radians r squared, and we know that the perimeter is going to be just the angle, which I've not defined, the angle times the radius plus 2 radiuses. Now I have a suspicion that some of the radiuses will cancel, so I'm not going to substitute it just yet. I'm just going to do it all in the algebra, and then we'll substitute at the end. Now we can replace the area with 4 perimeters, because it tells us that we can, it's given. And now you can see that it's quite straightforward, because we've got a formula with theta. We know what r is, so we don't need to worry about that. We've got perimeter and theta here, perimeter and theta, 2 equations with 2 unknowns. We can just eliminate the angle and have a formula for P. So I think probably if we rearrange this one, because there's no adding and taking in it, so if we get rid of the half, times it by 2, we're going to end up with 8p, having times by 2, and then we'll have to divide by r squared, and we'll get theta is 8p over r squared, and we'll substitute that into here. So p equals 8p r over r squared plus 2r. And of course we can get rid of that r and that squared, because they cancel out, r divided by r. And we just need to get all the p's onto one side now. So we need to say that p minus 8p over r equals 2r. And factorize out the p and say p times 1 minus 8 over r equals 2r. And then I'll have to come up slightly here to write the last bit down. Divide by the bracket. perimeter is 2r over 1 minus 8 over r, which I don't like having fractions within fractions, but I'm not too fussed. I'm just going to substitute the 28 in. I can put that all in my calculator with r as 28, and it will come out with the value of p. I'm not going to do that. That's because I've got it just down to the type it in the calculator stage. I'll leave you to look at that. If you have any questions about arc length and sector areas, then you can put them down in the comments. But hopefully that gives you a relatively good idea of how to use these formulae to answer questions about arc length, sector area. And don't forget, you can always do the segment area as well, just taking away the triangle using half AB sine theta to work out the area of the triangle, but possibly in radians. So just be careful of that. Thanks very much. Cheerio.